Good morning, everyone. I am Parul Preet Singh, Assistant Professor, CSC Department, MADE, Maharaja Agrisane University. Today, I am going to deliver a lecture on database management system. Topic discussed in this section: Introduction to Database Management System, key features of DBMS, advantages of DBMS, disadvantages of DBMS, applications of DBMS, difference between file system and DBMS, data independence, physical level data independence, logical level data independence. These are the topics which we are going to cover in this section. Starting from introduction to database management system. Before directly coming to the topic, we need to understand few basic things which are used in database management system. The first is data. It is defined as representation of facts, concepts, or instruction in a formalized manner suitable for communication, interpretation, or processing by human or electronic machine. Data is represented with the help of characters like alphabets, special symbol, digits. Data is collection of raw facts. Data is required in the operation of any organization. We can derive meaningful conclusions from this data. Next term is field or data item, a set of characters which are used together to represent specific data element are called field. In the below mentioned example, you can see roll number, name, and marks are the various fields, and the information like roll number 200, name Priya, marks 74 is a single record. Then 201, roll number Rahul 82 is a second record. All these records collectively called file. Roll number, name, and marks are the fields here. Then is record. As I told you earlier, collection of fields is called a record. Example, class record for a student containing data field as roll number, name, marks. Then comes file. Collection of records is called as file. Now comes database. A database is an organized collection of data stored in a computer system and usually controlled by a database management system. The data in common databases is modeled in tables, making queries and processing efficient. Structured query language, SQL, is commonly used for data query and writing. The database is an essential part of our life. We encounter several activities that involves our interaction with database. For example, in the bank, in the railway station, in school, in a grocery store, there are the instances where we need to store a large amount of data in one place and fetch these data easily. You can see a diagram where there is a table of customer and shipping table. It shows that data is being stored in one single location, and you can, with the help of customer detail and shipping detail, you can place order and where your consignment is. All these detail will be stored in the database at one single place. And when you require that data, it can be fetched from the database. A database is a collection of data that is organized, which is also called structured data. It can be accessed or stored in a computer system. It can be managed through a database management system, a software used to manage this data. That is called as database management system. Basically, database management system is a software system that is designed to manage and organize data in a structured manner. It allows users to create, modify, and query a database, as well as manage the security and access control of the database. Key features of DBMS is data modeling. A DBMS provides tools for creating and modifying data models which define the structure and relationship of data in a database. Data stored and retrieved. A DBMS is responsible for storing and retrieving data from the database and can provide various methods for searching and querying the data. Concurrency control. A DBMS provides mechanism for controlling concurrency access to the database to ensure that multiple users can use the data without conflicting with each other. Data integrity and security. A DBMS provides tools for enforcing data integrity and security constraints, such as constraints on the values of data and access control that restrict who can access that data. Then is backup and recovery. A DBMS provides mechanism for backupping and recovering the data in an event of a system failure. DBMS can be classified into two types, relational DBMS and non-relational DBMS. RDBMS data is organized in the form of tables, and each table has a set of rows and columns. The data are related to each other through primary and foreign. Non-SQL data is organized in the form of key value pairs, documents, graph, or column based. They are designed to handle large-scale, high-performance scenarios. Then comes the various advantages of having database management system. The first one is data organization. A DBMS allows for the organization and storing of data in a very structured manner, making it easy to retrieve and query the data as needed. Then comes data integrity. A DBMS provides mechanism for enforcing data integrity, constraints such as constraints on the value of data and access control that restrict who can access that particular data. Then comes the advantage that is concurrent access. It means that multiple users can access the data without conflicting with each other. Next is data security. A DBMS provides tools for managing the security of the data, such as controlling access to the data and encrypting sensitive data. Then comes backup and recovery. A DBMS provides mechanism for backupping and recovering the data in an event of system failure. Data sharing. A DBMS allows multiple users to access and share the same data, which can be useful in a collaborative work environment. Then is few disadvantages of database management system. The first one is complexity. DBMS can be complex to set up and maintain, require specialized knowledge and skill. Performance overhead. The user of a DBMS can add overhead to the performance of an application, especially in case where high level of concurrency are required. Third is scalability. The use of a DBMS can limit the scalability of an application, since it requires the use of locking and other synchronization mechanism to ensure data consistency. Then is cost. The cost of purchasing, maintaining, and upgrading a DBMS can be high, especially for large or complex systems. Limited use case. Not all use cases are suitable for a DBMS. Some solutions do not need high reliability, consistency, or security, and may be better served by other type of data storages. Then come various application of DBMS. The first one is enterprise information, sales, accounting, human resource, manufacturing, online retainers can use database management system. Second is banking and financial sector. Banks maintain the customer detail, their account details, loans, banking transaction, credit card transaction, finances, storing the information about the sales and holdings, purchasing of financial stocks and bonds. All these information can be stored and retrieved very easily with the help of a database management system. Third is university, maintaining the information about student course, enrollment information, student grade, staff roles, their records. These all can be maintained with the help of a DBMS. Airline reservation scheduling is also a very big application of DBMS. Telecommunication, where prepaid, postpaid bill maintenance is also being done with the help of DBMS. So these all were the applications of database management system. Now there is a comparison between file system and DBMS. The file system is basically a way of arranging the file in a storage medium like a hard disk. The file system organizes the file and helps in retrieving all files when they are required. File system consists of different files which are grouped into directories. The directory further contain other folders and files. The file system performance basic operation like management, file naming, giving access rules, etc. You can see an example is being shown. New technology file system and extended file system are the examples of file systems. Now come database management system. Database management system is basically software that manages the collection of related data. It is used for storing data and retrieving the data effectively when it is needed. It also provides security measures for protecting the data from unauthorized access. In database management system, the data can be fetched by SQL queries and relational algebra. It provides mechanism for data recovery and data backup. You can see with the help of an example, the end user database management system, database application. Examples of database management systems are Oracle, MySQL, MS SQL Server. Next, there is certain differentiation that has been done on the basis of certain things between file system and DBMS. First is structure. The file system is a way of arranging the file in a storage medium within a computer. DBMS is a software for managing the database. Now come the second thing, that is data redundancy. Redundancy data can be present in a file system. In DBMS, there is no redundant data. So this is a big advantage of DBMS. Third is backup and recovery. In file system, it does not provide inbuilt mechanism for backup and recovery of data if it is lost. As compared to DBMS, it provides in-house tools for backup and recovery of data, even if it is lost. Next is query processing. There is no efficient query processing in file system. Efficient query processing is there in DBMS. Consistency. There is less data consistency in the file system. There is more data consistency because of the process of normalization in database management system. Then come complexity. File system is less complex as compared to DBMS. DBMS is more complex in handling as compared to file system. Then is security constraints. File system provide less security in the comparison to DBMS. DBMS has more secured mechanism as compared to file systems. Then comes cost. File system is less expensive than DBMS. It has a comparatively high cost than a file system, the DBMS system. Then come data independence. In file system, there is no data independence. In DBMS, data independence exists mainly of two types, logical data independence and physical data independence. Next is user access. Only one user can access data at a single point of time in file system, whereas in DBMS, multiple users can access data at a single time. Then comes sharing. Data is distributed in many files, so it is not easy to share data in file systems. In DBMS, due to centralized nature, data sharing is easier. Then comes data independence. Data independence is mainly defined as a property of DBM is that helps you to change the database schema at one level of a system without requiring to change the schema at the next level. It helps us to keep the data separate from all programs that makes us make use of it. We have namely two level of data independence. One is physical level data independence and second is logical level data independence. You can see that there are three level: external level, conceptual level, and physical level. Logical level data independence exists between external and conceptual, and physical data independence exists between physical level and conceptual level. You can see in the diagram. Now comes physical level data independence. It refers to the characteristics of being able to modify the physical schema without any alteration to the conceptual or logical schema done for optimization purposes. Example is the conceptual structure of database would not be affected by any change in storage size of the database system server. Changing from sequential to random access file is one such example. These alteration or modification to the physical structure may include utilizing new storage devices, modifying data structure used for storage, altering indexes, or using alternative file organization techniques. Next is logical level data independence. It refers characteristics of being able to modify the logical schema without affecting the external schema or application program. The user view of the data could not be affected by any changes to the conceptual view of the data. These changes may include insertion or deletion of attributes, altering table structure, entities, or relationship to the logical scale. Thank you. Thank you very much.